This is video on statics of planar forces. We are dealing with concurrent forces and we are solving equilibrium problems. Now you see, there is no limit to the number and types of problems we can have on this topic. We are trying to group them. So this video is devoted to some of the problems on spheres and cylinders or rollers. These type of problems, which, as you will see, can be solved by using principles of concurrent forces in equilibrium. In overall scenario, it's worth looking at where we stand in our entire study plan, which looks like this slide. That is statics, two parts, concurrent, non-concurrent. In each of these, there are resultant equilibrium problems, and in each equilibriums, there are applications. So this particular video is statics of planar forces, concurrent forces, equilibrium problems, and special type is cylinders and spheres. Okay. Now, it's worth remembering these three steps in all the problems. What are those? First, draw a free body, then settle geometry, and then write your statics equilibrium equation, that is sigma fx0 and sigma fy0. What I mean by settling geometry is any force which is inclined. See, we need its component, so we have to know its angle with horizontal. That's what I mean by settle geometry. Free body, as the video progresses, I'll tell you how to draw it. Now, few points here to remember. That when you are drawing free body, anytime there is tension force, it will always be away from the body. Whereas if there is reaction from a surface or other body, it will be directed towards the body. Now, when there are spheres, cylinders, rollers, etc., when they touch each other or when they touch ground or wall or any surface, that contact is supposed to be tangential and only at one point. And finally, if three forces act on a body and keep it in equilibrium, be assured that those forces have to be concurrent. Keep all these points at back of your mind. You don't have to remember them, but just be aware of them. And let's look at the problems. First problem says a circular roller of 1000 Newton and radius 20 centimeter hangs by a tie rod. Tie means tension rod, whose length is 40 centimeter and rests against a smooth vertical wall at C as shown in figure. Determine the tension in the tie rod and reactions at point C. Now here's the point C. Now you see, understand the problem. See, cylinder or this roller is held in position. One end is touching the wall by a tie rod. Means maybe you imagine a string. It is attached by a string, and that string somehow goes and gets tied to the center of the roller. Okay. Radius of the roller is given, and it is in this position. And if it is in this position, and if we know the weight, what we are expected to find is the tension in the rod and the reaction given out by the wall. So our first step, as I said, is draw the free body. What is free body? You free the body from the support and then draw all the forces which were acting on it, including the reactions given out by the support. So see, the roller has a weight, so naturally the 1000 Newton has to act from center and it will be directed downwards, being gravitational force. Then it is attached by the tie rod or a string. So it has to have tension, and as we said, the tension has to be away from the body. And lastly, it touches tangentially at a single point C to the wall. So in the contact is tangential, the reaction by Newton's third law comes out of the wall, which is normal to the wall. So it is horizontal. And direction is from C, it is coming on the body. See, So that's why this RC is towards right. See, there's a simple thing, a simple body, but there are many intricacies involved. 1000 Newton, I'm sure it acts from the center because it's gravitational force. T, it passes through center, I'm sure, because that's the way it is given, and its direction is upwards because the tension has to be away from the body. Now when it comes to RC, how do I know it horizontal? Because the wall is vertical, and because the contact is tangential, and because it's normal reaction from the wall, and because it is perpendicular to the wall, therefore it is horizontal. How do I know that RC is towards right and not towards left? The reason is reaction is given out by C on the body. So it is on the body, so it is towards right. Okay. Now how am I assured that RC passes through the center of the cylinder and not anywhere else? Well, I'm told that this cylinder is in equilibrium, it doesn't fall off. And it is, now we can see it is kept in equilibrium by three forces, namely 1000 Newton weight, the T and the RC. And if three forces keep a body in equilibrium, they have to be concurrent. That tells me that RC has no option but to pass through the center. Having done free body like this very confidently, all I have to do is settle geometry. Means what? What is inclined? T. I want to know its angle with horizontal. That is given in the lower figure indirectly. Because radius is 20, length of the rod is 50. In that triangle, base is 20, hypotenuse is 40, so angle is 60 degree. So I know angle of inclination of T is 60 degree. Once I am here, all I have to do is say that because body is in equilibrium, these forces have to obey sigma fx0 and sigma fy0. So all I do is take sum of all these forces in x direction, that is sigma fx, that is rc minus t cos 60, equate it to 0. Take component of all these forces in y direction, sigma fy equal to 0. I get t sin 60 minus 1000 equal to 0. Solve these two equations and we get our t and we get our rc. And that's what was asked. The tension in the tie rod and reaction from the wall. Okay, next problem. We have a smooth circular cylinder of a W and radius R rests in a V-shaped groove whose sides are inclined at alpha and beta to the horizontal as shown. Find the reactions Ra and Rb at the points of contact. See, here's a cylinder in a groove and these angles of inclination of these walls are given alpha, beta, 25, 65. And the weight is given as 500. This much information is given to us. And what is asked? Reaction given out at contact point A and reaction given out at contact point B. That is what is asked. Okay. First, we have to draw free body. See, all the possible forces we have to draw. What are the possible forces? One is weight for sure, which is 500 Newton. Another, cylinder touches at A, so reaction comes out of A, that is Ra. Another, cylinder touches at B, so reaction comes out of B, that is Rb. Now, let's be sure of all the directions. Why Ra and Rb are upward? Because they are coming from A on the body. So, Ra and Rb are upward. Okay. Now, and these are the only three forces, so they have to be concurrent. So far so good. Now I have to settle the geometry. Means Ra and Rb at what angle they are inclined at horizontal I need to find. How do I go about doing it? I go about like this. See, this cylinder touches at A. Now you see, when you draw it, the touch is not properly seen. At B it looks like it is touched at many places. But ideally what is expected is it touches only at one point tangentially. So say A. Now Contact is tangential, so normal reaction has to be perpendicular to the plane. So RA and RB are perpendicular to the respective planes, see? And therefore, their respective angles are 65 and 25. Let me explain. RA is perpendicular to the plane on whom the point A is there. That plane is inclined at 25 degree with horizontal, yes. So perpendicular to that plane must be inclined at 65 degree with horizontal. That's why RA is inclined at 65 degree with horizontal. Similarly, RB, that is inclined at 25 degree with horizontal. So see, we have managed many things. We have managed to see, we have managed the free body, and we know now all these forces at what angle they are inclined. So we are ready. We also know that these three forces together are keeping the cylinder in equilibrium. And therefore, all we have to do is write sigma fx0 and sigma fy0. So we write Ra cos 65 minus Rb cos 25 is equal to 0. And sigma fy equal to 0. That is Ra sin 65 plus Rb sin 25 minus 500 is equal to 0. Solve the two equations and you get your Ra and Rb. Let's look at the last problem. It says two smooth spheres of weight 100 Newton and radius 250 mm each are in equilibrium in horizontal channel of width 900 mm as shown in figure. Find the reaction at the surface of contact A, B, C and D. Assume all smooth surfaces. Whatever the problem, steps are same. Draw free body. For all the bodies, there are two cylinders. For each of these cylinders, I have drawn free body like before. See the weight, the reaction. 100 and RB and RC are easy to see. But see RD, let me explain. Both cylinders touch each other at D. That contact is supposed to be tangential. So, if you draw tangent to both these, there is a contact. And therefore, normal reaction will be normal to this tangent that is along the radius. Therefore, we know that RDs are along the line joining the two centers, because then only they can be along radius of both the cylinders. Therefore, I am sure how the direction of RD. Now, these points help me in settling the geometry for RD, because RD is the only inclined force. So look at this triangle, let's take it down. Hypotenuse of this triangle is necessarily summation of radius, 250 plus 250. And the base of this triangle is 400. Why? Total channel width is 900. Subtract radius of left cylinder 250, right cylinder 250. The base of the triangle comes 900 minus 250 minus 250. That is 900 minus 500. That is 400. We have enough information for the triangle to know the vertical side and therefore the angle. And therefore we know that RD is inclined at 36.87. Now all you do is write sigma fx and sigma fy for each of the cylinder. For upper cylinder, sigma fy is equal to RD sin 36.87 minus 100. So you get RD. Sigma fx for the upper cylinder is RC minus RD sin 36.87 equal to 0. So you get RC. Do same thing for the lower cylinder, sigma fx and sigma fy to get to RA and RB. And thus we have found all the reactions. Thank you.